I'm Tim Naylor, the Vice President of Sales and Marketing at RefTec International Systems. I'm here today in lovely Punta Gorda, Florida, to discuss with you some of the key benefits and features of our new RefTec Bulldog Refrigerant Reclaim System. Rick Rowland with Certified Refrigerant Services will be joining us shortly, and he's been kind enough to let us use his facility to show you some of the key benefits and features. The Bulldog system is composed of 4 modules that will allow your company to perform functions such as large-scale recovery all the way to cleaning gas back to ARI 700 standards. ARI 700 standards, in simple terms, means taking dirty refrigerant and cleaning it back to new standards to be resold into the marketplace. The first part of the Bulldog system is the Bulldog itself. This model can be fitted with either a 5, 10, or 15 horsepower compressor to best fit the size of the jobs your company frequents. The Bulldog unit itself is a 460 volt 3-phase unit. If you don't have those power requirements available on the job site, a transformer can be used without hindering the performance of the unit. This single unit is capable of recovering many types of refrigerants from R11 and 123 to 134A, 22, 502, and even 410A. In order to meet the ARI 700 standards, 10 parts per million moisture content, RefTec utilizes the high flow rate desiccant bed. This desiccant bed can be used when producing ARI 700 standard gas or on larger chiller systems with high moisture content. The final module on the Bulldog Reclaim system handles non-condensable air that's sent to your bottles after processing. In order to keep your bottles filled with the most profit-making product and the least amount of air, we utilize the RefTec Mini Purge. This unit directly works off the bottle, purging out any air, giving you the most room for profitable product. These units are standardly used for startups and emergencies in chiller rooms, but are now commonplace on work trucks to handle most large chillers. So at this point in time, I want to introduce you to Rick Rowland. Rick's going to go over some of the major design features of the Bulldog and also guide you through the proper setup for a recycling and reclaim process. Here you go, Rick.
Thank you. Some of the features that make this a really unique unit is the idea that it's small and compact for the idea, but it's really doing a lot of work. So if we're going to do that, we want to take dirty refrigerant, oily, water, whatever it might be, the impurities in refrigerant, and we're going to distill them in this still. It's the main feature of that unit. We're going to do it automatically. So here it has an inlet valve and a solenoid. It's controlled by floats that are inside, so it automatically fills up, and the operation is automatic to add refrigerant to the still. When you come in further, Jerry, the compressor is here. We have an inlet gauge and a discharge gauge, and through the operation you'll need to look at those. So understanding that the low pressure gauge is the inlet pressure, the outlet pressure is this. We have a liquid trap on the front side that protects this compressor in case something were to go wrong and you were to get refrigerant up to the compressor, liquid refrigerant up to the compressor. So from there, you can see we've insulated the discharge. This is where the gas is coming back out. When it actually is clean and leaving the machine, that's what this would be. So there's an outlet valve and a sampling port here. This is also used when they de-inventory the machine. The leaving liquid goes into an appendage, if you would, or an option, which is a condensing or de-superheat unit that they make. If you're doing larger jobs, you would go ahead and get this. Smaller ones, it may not be necessary, but it's a neat unit for the de-superheating or changing that liquid and getting it even colder when it leaves. The hookup, we have a source tank here with dirty refrigerant. So we've got a 1/2-inch hose. We've connected this to the liquid port. We connect that to the inlet solenoid here. So when we get ready, we would hook up the inlet port. We would open this valve. The next thing we would do is the destination, or the leaving liquid, is going to be here. We would hook that to the condensing unit that we're going to use. This line would be hooked up to the destination tank. And so with all that tightened up and getting ready to go, the next thing we would do is that we put a test port and a sample port here. We're going to hook up our vacuum pump. So when we open that, get the vacuum pump running, we open all this, we would be able to vacuum to a good micron level this entire machine, including the hoses, all the way back to the source tank, so that we would know that we don't have refrigerant or air in the system before we get it started. With that done, then we could then isolate the vacuum pump and take it away. Then we'd be ready to get started and go ahead and process refrigerant. You know, I want to compliment RefTec on what they've got here. There's a need to have a simple, straightforward reclaim machine for the industry, and I think they've done a good job. The components are very fundamental, they're very basic, but they're also very sturdy. It's compact, it runs really well, and so I want to compliment them for the design that we've got here. Got it hooked up. We're about ready to process some gas here for you, show you how it runs. Right now, Jerry, we're getting ready to cook this down to see how much oil we got out of the last 68 or so pounds that we processed. But this is an automatic feature, but we're going to close that valve just so that the level of refrigerant will go down. When it gets down and pulls into a vacuum, we'll have all that refrigerant boiled out. Then we'll drain it. We'll see what kind of oil we get out of it.
You bypass it?
I got to turn it off right now.
Oh, you do?
We're setting and we're boiling the remaining refrigerant out of the vessels. But you can see the suction pressure right now is about 45 pounds. But when the material's gone in there, it'll pull down to zero. We've got units that are meant to be recovery units with a bigger compressor, and it actually pull down into a good vacuum. But this is a recycling unit, so it wouldn't really pull down into that deep vacuum. So if you look at it now, we're at about 40 pounds. We're going to go ahead and just wait till that comes down to right around zero. Let all that refrigerant boil out of there, and we're done processing what was in the machine. We stopped putting material in it, so we're just boiling away what's in the machine. You can see the suction pressure is down at about zero. We're just going to do a little check and see what kind of oil we got out of the last 80 pounds of refrigerant that we processed. So we're going to stop the compressor. You can see the pressure stays at zero, or right close to zero. If it's in a vacuum, we're going to suck some air in, so we may take a little bit of effort to try to make sure we don't get air in it, but let's see what happens when we try to drain the oil out. You going to look at that, Jerry, close up? Ah, we're getting some good stuff. Check that out. Yep. So that's the nasties we got out of that last 86 pounds of stuff that we processed. But seems like this stuff might be 4 or 5% oil. So it's not low in oil, but it's not extremely high. In the normal process, we would probably stop every 400 or 500 pounds and just try to drain the vessel, because if you continue to fill this up with refrigerant and you get more and more oil in there, you're boiling off more oily refrigerant and oil mixes. So if we could stop and get that out, and it's real simple just to get started over again. If we turn the compressor back on, open the valve back up, we go right back into operation. So after that, it's all automatic, but now that we got that oil out of there, the stuff that's in the bottom won't be hardly as high in content of oil. Tim, if we were at the end of a batch, let's say that this tank with 1,000 pounds in it that we had, we'd process that till it's empty. The Bulldog will go ahead and pull that into a vacuum, and what we would do then is we'd realize that the pressure, the suction pressure went down to zero, that we had pulled all that refrigerant through there, but we would still have some refrigerant in from the exhaust port of the compressor through the hoses through our de-superheat or our condenser here and all the way up to the liquid, we would have some refrigerant in there, and we don't want to waste that refrigerant. So what we would do is go to the destination tank, close off that valve. We've got a small service port down here. What we would do then is to put a recovery unit like the Diablo on this. We hook up our hoses and hook to this, and we could recover the refrigerant that's in these lines and all the way back up to the compressor, so that we really didn't lose any refrigerant at the end of this batch. So we would have really no losses involved. That would be how we would terminate or end that. If we had a specific refrigerant that we're running, we want to switch over to a different refrigerant. The thing we would do then is after that we would have to come over here and hook up a vacuum pump so that we could evacuate the unit into a deep vacuum before we started on a different refrigerant. We were talking about the final steps or polishing in the refrigerant. The RefTec Bulldog does a great job of reclaiming and taking the water and oils, particulate, those kind of things, the acid out of the refrigerant. But when it comes out, it would then go through the polishing bed to finish taking the moisture out. And as we put this material then into a destination tank over here, that pure tank will be collecting the clean, dry refrigerant. One last step that we might consider is that the ARI standard says that you shouldn't have less than 1.5% air in that refrigerant for it to meet the ARI standard. The RefTec Mini Purge is a unit that works really well. We have a destination tank like that. We would put that Mini Purge on that unit and let it service or polish the air off of that. So that's the final step in trying to remove the air that might be on our pure refrigerant in that destination cylinder. One of the things that Tim likes about this unit is you can stand around and watch it run and still have a conversation. So I think it's pretty amazing the work it does and the sound level that it works at. So you can still hear Tim talking, which is, I don't know, good thing?
Sometimes it's a good thing. Well, Rick, I want to thank you for the test run here.
Okay.
Provided us with and the use of the gas in your facility. A couple things I wanted to touch on again is this is the 5 horsepower unit. We do offer this in a 10 and 15 horsepower unit. Same dimensions except for height. This unit is capable of fitting through normal standard doorways, so it is a portable unit, as well as it can handle longer hoses, so you can leave it on the back of your truck as you're running the job inside a facility. Rick, thank you again.
Okay, look forward to it.
Folks, I want to thank you for watching the video. Look forward to Rick and myself getting back into the booth here and shooting some other videos on how the Bulldog can pull down ISOs, as well as using the Bulldog in a kidney loop on a running chiller without taking it offline. Thank you very much, and we'll see you again soon.